All right, friends, so let's understand what is variance inflation factor. So I'm going to pull my slide over here. A variance in inflation factor is a measure of the amount of multicollinearity in regression analysis. So let's take a deep dive into that. What does it mean? So we know that any target variable can be represented in a multilinear regression as a product of the coefficient x1 and the weights applied to that m1. Likewise, m2 into x2, and likewise other variables that x3 and x4 may have their own weights, and finally a bias attached to that. Imagine the variable x1 and x2 have some kind of a correlation between them. What would happen? Well, that would affect our uh, target variable prediction, and this is what we call it. There is an adverse effect on the regression results. Thus, the variance inflation factor can estimate how much the variance of a regression coefficient is inflated due to multicollinearity. So I hope you got a bit of a context. Let's deep dive into the next page. Over here, a large VIF on an independent variable indicates a high collinear relationship to the other variables, while the multicollinearity exists when there is a linear relationship or correlation between one or more of the independent variables. So it's obvious, given the data set and we have all the features, anywhere from 1 to 5 or 10 features, depending on how large is the feature set, there could be multicollinearity between them. And our job is to make sure we reduce the multicollinearity so that we don't have biased results, or our predictions are more accurate because we have removed the dependent variables. All right, so problem with the multicollinearity is it basically creates a problem in the multiple regression model because the inputs are all influencing each other. Therefore, they are not actually independent. And our job is to make sure them dependent variable. So if I talk about x1, x2, x3, x4, x5 in the previous equation, then I want all the independent variables, not having any correlation between them. That's the whole idea of making them independent variable. And it is actually difficult to test how much the combination of independent variables affect the dependent variables or outcome within the regression model. But you have seen the example how I was able to calculate the VIF factor, and based on that, I should be able to eliminate the features which I don't need because they probably have a higher multicollinearity. I can still take the variables which have low and medium values, and that's what we're going to execute in our next subsequent sections. But before I deep dive into the next, let's take a look at the value sets for the VIF. So the VIF equal to 1 means variables are not correlated. So that's a good indication. And VIF between 1 to 5 is moderately correlated. And anything greater than 5 means they are highly correlated. So we need to eliminate in our example if we see engine versus price here, whichever has a highest VIF value, we need to immediately cut it off from our data frame in order to process and train the data model, right? So let's take another example. This I'm taking from Investopedia. So we see different variables: age, weight, body surface, duration of hypertension, pulse, stress. We see there is a correlation with blood pressure. There's a correlation of weight with respect to age. There's a body surface area has a relation again with the weight. So what we can derive over here is, rather than taking body surface area in my data set, I can just carry on with the weight and age. It makes sense rather than carrying a dependent variable weight and body surface because there is a high multicollinearity of 8, which is about 5. So that's kind of a sense we are making out of this slide. Okay, so let's do one thing. I'm going to close the lecture. I'm going to see you in the next lecture, and thanks for joining.